Hi guys, welcome to another video of Physics 2. This is the problem number 2 about free fall. So let's do it. It says a person is standing on a 53 meters high bridge from the water, drops a rock and watches its motion until it touches the water. Okay, answer the following. How much time did the rock take to touch the water? And what is the velocity of the rock when touching the water? Okay, so I'm gonna make the drawing here. I'm going to suppose that, well, this is the bridge, something like this, and the person is right here. Okay, and this person drops a rock and the water is over here. Splash. Okay, that's it. Remember that, okay, I'm gonna change the color purple. Remember that this is the initial position, and the initial position is the height. So in this case is 53. Also, I got initial velocity. Remember, initial position, initial velocity. Initial is where the motion starts. So in this case, the initial velocity is 0 meters per second, because I said that in the previous video about free fall, that the initial velocity is always 0. Okay, this is the final position, is where the motion ends. Final position in this case is always 0 meters because that's the height. Okay, final velocity, okay, in this case I don't know the final velocity. I got acceleration, that is the value of the gravity, that is minus 9.8 meters per second square. And also, well, and the time. I don't have the time. The time that it took the rock to touch the water. Okay, how much is that? And this is the drawing. Okay, remember that this is a free fall problem because it says a person drops. That means that this person let the rock go. Okay, so I'm gonna make the problem here and this on this is a screen. So let's write the data first. Data, I'm gonna write it again. Okay, so initial position is 53 meters. Initial velocity is 0 meters per second. Acceleration is the value of the gravity, that is minus 9.8 meters per second square. What else? The final position is 0 meters. And I guess that's it. I'm gonna write the equation. The first equation that I'm gonna write is the acceleration equals final velocity minus initial velocity over time. So with another color, I'm gonna check all the things that I have and I don't have. So acceleration, yes, I have it. Final velocity, nope, I don't have final velocity. I forgot to write that data over here. Final velocity, no, I don't know the velocity. Remember that it's free fall, so that means that the final velocity will be negative because remember the reference system, everything that goes down is negative. So final velocity, no, I don't have it. Oops, let's write it with red. Initial velocity 0, yeah, I have it. And time, nope, I don't have it. So remember, if an equation has 2 or more cross marks, I cannot use that equation. So I need to go to the other equation, that is final position equals initial position plus initial velocity that multiplies the time plus acceleration times square over 2. Okay, so final position, yes, is 0. Initial position, well, I got it, is 53 meters according to the data that I just wrote. Okay, this one over here. So initial position is 0 meters per second, so I have it. Time, I don't have it. Acceleration is the value of the gravity, and time, I don't have it. But I got, you can say that I got 2 cross marks, but it is the same value. And also I'm gonna cancel all the things that are 0. So final position is 0. And initial velocity that multiplies the time will be 0, 2. So these two terms are gonna be canceled. So let's continue writing the equation. This is 0 equals initial position plus acceleration that multiplies time squared over 2. So from this equation, I'm going to isolate the value of time, okay? So the first thing that I'm going to do, well, I can move this whole term over here. I can move it to the left. Okay, so it will be minus acceleration times square over 2 equals initial position. Okay, so this 2 that is here, it's dividing, so those goes multiplying, and the acceleration with the negative sign is multiplying the time, so it goes to the other side dividing. So yes, let's do it. And the exponent, the square, well, I'm gonna get rid of that square with the square root. Okay, so time equals 2 times the initial position over the negative acceleration. Now this negative could be in the denominator or could be in the numerator, as you wish. I'm gonna write it, I'm not gonna write it there, I'm gonna write it here. Okay, I'm gonna rewrite the equation because I'm gonna write that negative sign in the numerator, minus 2 times the initial position over the value of the acceleration, and everything is going to be inside of a square root. And if you want, you can circle this equation and you can say that this is the equation to find time in free fall, but only in free fall. If we got another type of motion, as we are going to see in the future videos, I won't be able to use this equation. Now just remember that I use initial position because that is the value of my height. If you want to use that the final position is the value of your height, well, it's up to you. But this is how I wanted to write the data. Okay, so I repeat, this equation can only be used in free fall. So let's do it. I'm gonna make it over here. Yeah, I'm gonna write it here. So time equals minus 2 times 53 meters over the value of the acceleration, that is the value of the gravity, that is minus 9.8 meters per second square. And this will be inside of a square root. Okay, so meters goes with meters and the square goes with the square root. Okay, so let's do it in the calculator. Square root and then fraction, minus 2 times 53 over minus 9.8 equals, how much is that in decimal? Okay, this is the value of the time. It's an infinite value, so I'm gonna save this value in my memory. Shift STOA. Okay, and I'm gonna write the answer. Time equals 3.28 88 seconds. I'm gonna circle it with red because that is a question. How much does it take to touch the water? And this is saved in the memory A. Now that I got the time, I can return to the previous equation, this one over here. Now I can say that I got the time. Okay, now I got the time. So what is the question? What is the final velocity? Okay. So from this equation, before I do it, I can cancel initial velocity because initial velocity is 0 in free fall, and acceleration equals final velocity over time. So final velocity equals acceleration that multiplies the time. And if you want, you can circle this equation and you can write that this is the final velocity in free fall. Only in free fall. Okay, if we got another type of problems, the final velocity will not be found using that equation. But remember that all the equations come from these two equations that I got over here, the same equations that I have used over and over again. So final velocity equals the value of the acceleration minus 9.8 meters per second square multiplies the value of the time, 3.28 seconds. So let's do it in the calculator. Minus 9.8, that multiplies the value that I got saved in the memory A of my calculator, and that is the final velocity. I'm gonna write it here. Final velocity of the stone is minus, remember, is negative because it goes down, 0.2304 meters per seconds. And I'm gonna circle that answer because that is something that the problem asked me to find. Okay, so this was the problem number 2. I hope you understood. These are the two new equations if you want to write them. If you don't want to write them, it's not really necessary because remember, these two equations come from these two original equations that I have. And probably in the future videos, we are going to find more equations that, again, they come from these two equations over here. Okay? Well, guys, I hope I see you in the next video. Bye-bye.